Hey guys, this video is going to go over factoring out a GCF, also known as a greatest common factor. Now, you've probably heard of GCF before from middle school. In middle school, what you guys would do would be like, hey, find the GCF between 12 and 16. So I'm basically trying to find the biggest number that goes into both 12 and 16. So the way you might have done it is you drew a T-chart. So let's think of things that multiply and make 12. I will preface this by saying if you are struggling with multiplication facts, please reach out to me so I can help you with this section. But this is going to rely heavily on your multiplication facts and knowing your division facts as well. So things that multiply to 12 would be 1 times 12, 2 times 6, and 3 times 4. Those are all the combinations that I could get to multiply by 12. Now I could write 6 times 2, but that's basically the same thing as 2 times 6. Okay, 16, 1 times 16, 2 times 8, and 4 times 4. So the GCF, or the greatest common factor, would be the highest number that they have in common. So I would look at all the numbers and be like, hey, what's the biggest number they have in common here? And the biggest number they have in common is 4. Now they do have the number 2 in common, but that's not the greatest. So you do want to go for the greatest. So here our GCF, greatest common factor, is 4. Now in algebra, you do need to know how to do it with letters, so I'm going to show you how to do that now. Now we want to compare x cubed and x to the 5th. What does x cubed mean? Well, that means I have x times itself 3 times. It means I have x times x times x. Okay? X to the 5th is x times x times x times x times x. I have x times itself 5 times. So your goal here is to find the greatest amount of x's that goes into both, right? So comparing both of these x's, I have 3 on the left and I have 5 on the right. What's the most amount of x's that can go into both? The most amount is 3 x's. So their GCF is going to be x cubed. So typically when we're talking about GCF of variables, it's whatever the smallest one is. So if I'm talking about x squared and x to the 7th, right? X squared means x times x. And x to the 7th is x times itself 7 times. Okay? So over here, I'm going to go ahead and show you with the previous example. I was able to get in common 3 x's with each other, and that's the most amount that would go into both. Over here, what's the most amount that can go into both? Well, 1 can go into both, and 2 can go into both. Can 3 go into both? No. So my GCF here would be x squared, okay? So this is just the beginning. So that's we're going to use these skills to when we actually factor out the greatest common factor. But the important thing to know here is that factoring is the opposite of distributing. It's the complete opposite. Back in Unit 1, when you learned how to distribute, you would have 3, and then you'd have like x plus 7, and I'd ask you to distribute. Well, distribute means I'm going to multiply the outside number to everything inside the parentheses. Distribution is the operation of multiplication. 3 times x is going to give me 3x. 3 times 7 is going to give me 21. I'm distributing. I am multiplying. So if distributing means multiplying, then what do you think factoring might mean if it's the opposite? Factoring is going to be division. So distribution is multiplying, factoring is dividing. So we're going to start with our examples here. We have example number 1, 4x squared y squared plus 16xy. Okay, the first thing you want to note is how many terms do you have? I see that I have 2 terms, okay? Now, remember, when you're factoring, it is the opposite of distributing. So, for example, they've given us a problem that's already been distributed, and we have to undo that distribution, okay? So, I have 2 terms. When I figure out how many terms I have, that's how many division bars I'm going to write. Why am I dividing? Because remember, factoring is the opposite of distribution. So, instead of multiplying, I'm dividing. Okay, so now, the way I like to do it is I like to do things that are in common with each other. This video is going to go over a little over 5 minutes just because I want to make sure this is understood, because in order to factor trinomials, which is what we're doing for the next 3 assignments, you need to know how to do this lesson. So the first thing I look at is the regular number in the front, the coefficient. So my numbers in the front are 4 and 16. What's the biggest number that goes into both? The biggest number that divides into both is going to be 4, right? If I were to make a chart up here of all of my factors, the biggest number that goes into both is 4. So that's going to be what I write down on both. I'm going to write down the exact same thing on both because I want to do it. Anything I do to one, I have to do to the other. Okay, now the next thing I see is the x's. So I like to do things in order. You can do whatever you want, but I noticed that I have x's next. Well, how many x's are over here? Here I have 2 x's. I have x times x. Over here, I just have 1 x. So what's the most amount of x's that goes into both? Just 1. Okay? You can't take out more than you already have. Okay, the last thing I see is the y's. Over here, I have y squared, which means I have 2 y's. Over here, it's just y to the first, which means I only have 1 y. Well, what's the most amount of y's that I can take out of both? Both. Remember, you have to be able to take it out of everything. It's going to be just 1 y. So, let me go ahead and go backtrack. The goal is you want to take out the greatest common factor. You're trying to take out the greatest amount that you can. So the greatest number that I can take out of both is 4. The greatest amount of x's I can take out of both is just 1x. And the greatest amount of y's I can take out of both is just y. Now remember that factoring is dividing and distributing is multiplication. So we're undoing distribution. So when we distribute, what happens to the parentheses? They go away, right? So if I'm going backwards, I got to put those parentheses back in place. So this number that we write out, or this term that we write out here, should always be the same for all of your terms. That's going to go on the outside of your parentheses. Okay, you're undoing the distribution. You're taking it back out. And then inside your parentheses, I call them leftovers. So we're going to go ahead and divide. 4 divided by 4, right here, what does that equal? It equals 1, right? 4 divided by 4 is 1. X squared divided by x is just x. You can think about it, where there are more x's, there's more x's at the top, there's 1 x at the top. You can think about it like subtraction as well. If I have 2 y's in the top and I have 1 y in the bottom and I take that away, I only have 1 y left. Okay, moving on to the next part. 16 divided by 4, remember this is a division bar, 16 divided by 4 is positive 4. You want to make sure you have that plus sign there. Now x divided by x actually cancels, right? Because if I have an x and I take away that only x, how many x's do I have left? Nothing. If I have 1 y and I'm taking out a y, I have no y's left. So this is what I'm left with. And this is my answer. Okay? So the hardest part about this is basically being able to go back and think, how many things can I take out of each thing? Okay? All right. So where'd the 4xy come from? That was our GCF. Okay, we took out the greatest common factor and we took it back out. We're undoing the distribution. If I wanted to redistribute this, I could distribute everything back in. But we don't want to distribute for our final answer. Okay, moving on to the second example. How many terms do I have here? I have 3 terms. So I'm going to write 3 division bars under all of my terms. Or not all under my terms. On each term, I'm going to write 1 division bar. So I have 3 here. So when I'm talking about the greatest thing that goes into all of them, I have to think about it for every single term. So I like to look at the coefficients first. I have 2, 8, and 6. Now I know that 8 is negative, but it doesn't really matter. So I'm just going to keep it as an 8. Okay? And I have 2, 8, and 6. All right, well, what's the largest number that can divide out of 2, 8, and 6? It has to go into all of them. Can 4 go into all of these? No. The greatest number that can divide out of all is going to be 2. Out of 2, 8, and 6, the greatest number is 2. The next thing is the x's. In the first term, I have 3 x's. In the second term, I have 2. And in the last, I only have 1. So what's the greatest amount of x's that I can take out of every single term? Only 1. If I try to take out more than 1, this guy's going to be in debt, right? Because he doesn't have enough. He only has 1x, so that's the most we can take out. Now, where does that GCF go? Where does this 2x go? That 2x is going to go on the outside of your parentheses, right? We're undoing distribution, okay? We're factoring. That's what factoring is undoing the distribution. So you're taking the 2x out, you're taking it all out, and now we're going to simplify. 2 divided by 2 is going to give me 1, okay? 2 divided by 2. Over here, if I have 3 x's and I take out one of the x's, I still have x squared left. Now, is the 1 in the front necessary for you to write? No. And if you're doing homework through Pearson, I might not like you writing the 1, so it just depends. You can try it both ways and see what works. Okay, so in the first term, all I have left is x squared. Moving on to the next term. Negative 8 divided by 2 is going to be negative 4. Negative 8 divided by positive 2. Okay, and then I have 2 x's and I'm taking 1 x away. If I have 2 and I'm taking 1 away, I have 1 x left. All right? The next thing I'm going to do is 6 divided by 2, which is going to be positive 3. And then x divided by x cancels, because if I have an x and I take away the only x that I have no x's left. So this is going to be my final simplified form. I factored out the GCF. The GCF, the greatest common factor here, is 2x. And lastly, we have 3k minus 12k squared g plus 30k to the 5th. Okay, here I have 3 terms, so I know I'm going to write 3 division bars. All right, I'm going to look at my coefficients first. I have 3, 12, and 30. What is the largest number that goes into all 3 terms? The largest number that goes into all 3 coefficients is going to be 3. Okay, 6 can go into 30 and 6 can go into 12, but 6 cannot go to 3, right? Because the only factors of 3 are 1 and 3, so we can't go anything bigger than that. All right, the next variable I see is the k's. Now, the first term has 1k, the second has 2, and the last one has 5. So what's the most amount of k's that I can factor out here? Only 1. I can only take out 1k. The reason why is because this guy only has 1. If I take out too much, we're going to be in debt. Now the next variable I see is this g here. Can I take out a g from every term? No. The first term does not have a g, and neither does the last term. So if that's the case, I cannot take out any g's. So the largest thing I could take out, my greatest common factor, is going to be 3k. Okay? And then in the inside of my parentheses are my leftovers. I'm undoing the distribution, so we're going to figure out what we had from the beginning, right? Now 3 divided by 3 is what? It's 1, correct? 3 divided by 3 is 1. K divided by k is going to cancel. Now sometimes people cancel the entire thing here, but that doesn't mean it's equal to 0 because 3 divided by 3 is 1. So you want to make sure that you do write a 1 there. Okay, it is not 0. Okay, the next thing we have is negative 12 divided by 3, which is negative 4. We have 2 k's, and we take away a k, so we're going to have 1 k left over, and the g is going to stay exactly as is because we weren't able to take out anything. The next term, 30 divided by 3 is positive 10. If I have 5 k's and I take out 1 k, I still have k to the 4th. And so that is factoring out a GCF, or a greatest common factor.